Hello everybody, let's solve Leetcode question 2375. Construct smallest number from di string. We are given a zero index string pattern of length n which consists of characters I and d. We have to create a number of length n plus 1 uh, with the following conditions. So the number must contain digits from 1 to 9 where we can use the digits at most once. If the character at the ith index is I, it means the number at ith index should be less than I plus first index. And if it is D, then it should be greater than the I plus first index. We have to return the smallest possible number that follow these conditions. Okay, let's look at an example. Okay, so we have this pattern, right? Pattern of length 8. So we have to generate a string of length 9 because we are given I characters, like 8 characters. We have to uh, create a string of n plus 1 characters. Okay, so our number will have the digits from 1 till 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have to create the smallest lexicographical string possible, which should also follow these conditions. The most brute force approach that we can think of is we can generate all the um, possible strings, right? Number combinations from these digits, and then we can compare and match which of compare and match if the following conditions are followed, and out of those strings we can choose the smallest one, right? But the time complexity of that will be in the order of n factorial, right? N factorial to check and to n factorial to generate all the possible combinations, and then again we have to check, then we again multiply this by n. So this is the time complexity of that case, which can be accepted because the test cases are the length of the pattern is just eight characters, right? So it should be possible to solve this, but we can solve it much faster. Let's consider a simple pattern I I I. So the pattern length is 3, so there are four digits that we have to choose from, and we can choose any digit, right? We can choose 6, 7, 8, 9. We can choose 4, 5, 6, 7, which follow this pattern. But the smallest one will be 1, 2, 3, 4. 1, 2, 3, 4. Now let's add another character to this string pattern. What will happen if we add another I? So now the length will increase by 1, and we will have to choose one more character, and that will be 5. This is the smallest sequence possible. Okay, what if we had chosen a D instead of the psi, right? So let's choose a D. What will happen? The result will be 1, 2, 3, 5, and 4. If you take a look at this is the same sequence that we got earlier, but we just swapped the places because we needed a decreasing string. Okay, now let's increase this pattern length, right? Let's assume we have a pattern that has 3 i's and then 3 d's. So we know the resulting sequence will be of length 7, so it will be the 7 smallest numbers. So let's take the 7 smallest numbers: 1, 2, 3, 4, 5, 6, 7. Okay, so we have to just loop through this pattern, and we have to just swap the numbers if there's a d, right? Let's try run and try to see. So we have an I here, right? The next number is greater than this number that we are at currently, right? So this is a valid number, so we just skip ahead. Now we have parsed this. Now we are right here. Again, we check the same sequence pattern again. So I, which means the next number should be greater, which is greater. Great. So this is also done. Let's move ahead. The next number is greater, so this is also valid. So let's move ahead. Okay, so there is a D present here, right? Which means that the sequence should be decreasing, but we know the next number is increasing, so we have to swap these numbers. So let's swap them now, right? So once we swap them, the string will be 1, 2, 3, 5, 4, 6, 7, right? So this condition is matching now. So let's move ahead, right? Again, uh, so this condition is matching. Let's move ahead. So again, this is increasing, so we have to swap them again. So let's swap them. So after swapping them together, the string will be 1, 2, 3, 5, 6, 4, 7, right? And now if we see the earlier condition that we had, 5, 4, which was decreasing, has been invalidated again, right? So this is not what we were expecting. So thinking of what we can do, because we have to maintain these characters in the decreasing order, right? So we can just count how many digits are there that needs to be in the decreasing order, and then we can swap them, reverse the whole sequence itself. That will make sure that the sequence is in the decreasing order, right? So we'll solve the same, right? We have the numbers 1, 2, 3, 4, 5, 6, 7. So we know that this character is increasing. So we have parsed this. So this is valid, this is valid, this is valid, and we are right here now, right? So the character present is D, right? So we know that we have to swap. So we just go again ahead. So we know that we have to swap this number with this number. Let's go ahead. The next character is also D. So again, we have to swap till here. The next character is also D. So we have to swap till here, right? So we know that after this number, everything has to be swapped. So we'll just swap all the digits in between these two indexes. So we will have 1, 2, 3, 7, 6, 5, 4. And if we consider the pattern again, so this is increasing, this is increasing, this is increasing, this is decreasing, this is decreasing, this is decreasing, which is what our pattern also tells. And this is the smallest lexicographical thing possible. So thinking of the time complexity and the space complexity, the time complexity of this will be O of n, because we are parsing through the string only once, and we are keeping track of the indexes, and then we are swapping them. So and for the space complexity, we will need a resultant array to store the sequence. So we'll take O of n space. Let's write the solution for this. Initially, we'll need n. Let n be the length of the pattern, and we need to store the sequence for I in 1 till n plus 1. So we have to include n plus 1. So we'll just increment till n plus 2, and we will add string of I to the result. So this will have all the smallest digits possible. So once this is done, let's initialize the index that we are at in the pattern 0. And while the index is less than n, we run this loop till we reach the end of the pattern. So inside we need to keep that, we need to count the maximum, we need to count all the D's together, and then we have to swap those D's. If it is not a D, we can skip over that and continue, right? So let's initialize a variable temp, while temp is less than n, and pattern at temp equals D, temp plus equals 1. So we are counting all the consecutive D's that are there in the string. And once we have that, we'll reverse the array from index I to temp, right? And once this is done, if so if I is equal to temp, which means that we did not find any D, then we have to increment the index by 1. Otherwise, I will be temp. So it will be the end of the character. And once this is done, we just have to return the result. So let's implement the reverse function. Takes an array, it takes the left and right pointers. While L is less than R, result L, result R equals result, and L plus equals 1, R minus equals 1. Okay. This reverses the array from index L till R, and looks good. Let's try to run the test cases. Okay, test cases are accepted. Let's submit.